Hi, Eric. How are you doing today?
Good, Marvin.
Thanks for agreeing to have this session together with Thing Zero. I just wanted to kind of introduce what we're doing here today. We're going to be walking through, a classic scenario of helping manufacturers go from sort of a brownfield story to the path all the way through being able to do predictive AI. Uh, Eric is a partner of Thing Zero, both in his advising us how to bring data up and manage it through. I'll let you speak more properly about that, Eric, and then all the way to how we take business decisions. I'm Marvin Tansley. I'm one of the co founders of Thing Zero, and we are focusing really on how do you have secure predictive analytics that's scalable cloud wise, but the most important part is how do we improve your profitability? My background's in industrial engineering and worked in manufacturing for several years. And then I've been in security for the last 15 years and always looking at data and how we can improve profitability and productivity through for enterprises and manufacturing. Eric, turning it over to you for your introduction.
Yeah, I've been in the field of machine learning for more than 30 years. I'm a former Columbia professor and independent consultant for 21 years. Um, I'm the co-founder and CEO of Goodter AI for the last couple of years. Very excited to be partnering with Thing Zero. I am um, amazed by the team of various complementary talents that you guys have brought together, the vision, and your pipeline of and funnel of customers, amazing opportunities out there for anybody working with you.
Thank you so much. The pleasure is all ours. To me, it's amazing. You've written a couple great books. I've read through them. It makes complete sense. And thanks. Our whole team, as you said, is has each area of the expertise we need to be able to drive through there. So I think that what we wanted to talk through today was sort of a theoretical example of you get approached by a client. They're looking to do a digital transformation project. They approach you and say, "Hey, I've got this problem." And I would like to, start being able to collect data in real time. I have, down times that are represented in either predictive maintenance that needs to be done or improvement of in-process settings so that the quality remains in place. And it represents 30% of our equipment utilization. And so, how do we get started on this? What do you do? And so, given that as a problem, Eric, let's
Yeah.
go back and forth and talk about that.
So equipment regularly down about 30%, or at least not producing a quality high enough. And what's the revenue of this hypothetical company?
Well, let's just put them at a global scale where they're saying, "Hey, we need to operate in the United States. We need to operate in Europe. We need to operate in South America." Because this is where we've set all our facilities. And, as part of that, what I need to be able to do is pull data from all these locations. And, as a first state is I just need to know, are the machines running and how much are they producing? But ultimately, where I want to go to as this customer is like, how do I then look at is how do I look at a specific manufacturing process and say, I want this manufacturing process to improve because here's all the points where things, whether it's the speed of something or the heat or the external factors, I want to model that all together and start doing predictive analytics that can be acted on.
So the gold standard, predictive use case of predictive AI or predictive analytics is predictive maintenance for this type of scenario. Um, you know, if you're in that situation where there's this amazing throughput, maybe a very profitable circumstance, but 30% of the time it's actually not up to quality. Let's use the word down. So it's essentially down 30% of the time on average across all different kinds of equipment. That's an astonishing opportunity. And you know a brute force approach might be like, well, let's throw more work into periodic maintenance steps and what have you. But these typically disrupt flow, so they're very, very expensive. And in general, what you're always trying to balance at certain increments, maybe it's daily, hourly, monthly, it really depends on the equipment, on the type of equipment, is that balance between performing some kind of maintenance or preventative step that really costs something versus maybe conservatively avoiding that, but then potentially incurring a much greater cost when there's an unexpected outage. So you're kind of damned if you do, damned if you don't, right? There's a downside at each point that you're making this type of decision. It's going to cost you either way. So the the holy grail for driving that decision each time is prediction, or to be more concrete, what are the odds? I mean, in all of this kind of um, operational utility, it's a numbers game. Business in general is a numbers game, and very much so within a factory. So the the way to play that game more optimally is if you have the odds. If you're at this increment with this piece of equipment next Tuesday, and it's saying, hey, look, the odds of an outage in the next time increment, in the next day or whatever it is 3 times more likely than average, then the math, the sort of uh, cost benefit analysis right then and there, which is quite straightforward, is going to say, look, we should actually invest in this maintenance step, even though it means a brief intentional outage and maybe investment of other resources, rather than being laissez-faire, right? So that's driving the decision, is those odds. And if you have the odds, the decision is clear. The cost benefit is simple. I mean, I can just tell you what the math is right now. It's just, what's the probability of being wrong with option A times the potential cost if you're wrong, and what are the odds of being wrong if you went with the other option B, and the cost of that. You just multiply and multiply, and then you've got two what are called expected costs. You go with the lower cost at each time. So the key ingredient there is the probability, and the way we create those probabilities, those odds, is machine learning. So people don't normally talk about machine learning and AI in these terms because people like to qualify it as, quote, intelligent, and kind of go with the brand that's so exciting. But if you just want to get down to concrete value-driven use cases, it's about odds of an outcome that can then directly inform each individual, millions of operational decisions.
Yeah, that's great. And I think, in a lot of the practitioners I've worked with and in the scenarios we've been in, and what you cited in your book, that the majority of models don't end up being published or being applied.
Yeah.
And when you look at that, I have got a lot of thoughts into that, but what would you say are the largest contributing factor of why these models don't end up being used in after the effort's gone through in a pilot or a POC and it's gone to a pilot, but it ends up just kind of being a shelfware project?
Well, one of the main things is that there's not visibility from a business standpoint in a way that's non-technical and understandable and intuitive into what's the actual value and purpose of this, and what's the projected actual dollar or monetary savings you're going to get by implementing this type of decisioning process. So what you need to do, in addition to sort of learning from data to be able to produce those odds on the fly, and if you can do that acting on the odds, is a pretty straightforward concept. Um, but before you launch a system and put it into production, you need an aggregate view. You need an estimation of the total win and the total trade-offs that you're making in aggregate over many, many individual decisions. And that's usually the main piece that's missing. That's what we do at Goodter AI, is produce a solution that visualizes that and puts it into concrete terms and in monetary terms, savings and profit, and in a way that's understandable to the stakeholders, the business leaders and decision makers who need to work closely with data scientists and whoever's doing the number crunching and making those predictive models to understand what are the ramifications of this deployment. Of course, there are also other challenges. There are technical challenges, not the least of which is having the right data. And of course, that's where all of these highfalutin ideas that I've described here would go nowhere without the right data infrastructure there in the first place. So let me outline the broad data requirements for that type of predictive maintenance system, which is real straightforward. And then I'd like to hear from you, your take on it as far as the infrastructure that Thing Zero can help put in place to that end. So the
Perfect.
requirements are broadly kind of twofold. One is you need the right data from which to learn, and the other is you need the right data in real time during deployment when you're making these runtime predictions. So the first part is, well, to make this model, you need enough both positive and negative examples from which to learn. So for example, if you're predicting, at 3 times a day, will this type of equipment see an outage or whatever the threshold is for poor performance, right? So will it see negative and a negative outcome rather than a positive? So you need both examples of that negative outcome and everything that was known prior to that, the inputs to the model, the things that you're going to use to make that prediction. And then you have the history has spoken, data is experience from which to learn. That's another definition of machine learning, is learning from experience, and data represents the collective experience of an organization. So that experience is in the form of historical cases where you found out whether things went left or right, positive or negative. Those are learning cases, training examples from which to learn, put them together. That's called the training data. So we need that, but we also need a very similar data set moving forward and kept up to the current moment, so that what's been learned, which is in the form of what's called a model, a predictive model, then can take the current inputs regarding the particular equipment for which you're trying to make a prediction. And it needs up to the moment in the same exact format and form, the same semantics, the same exact kind of data that you had in the historical learning data, now up to the present. Of course, you don't know the outcome right now. That's the whole point. That's why we're making a prediction. The future is the ultimate unknown, right? But what we're doing is we're kind of penetrating the fog of the future and putting odds on it, right? We don't have a magic crystal ball, but we have the next best thing, which is the odds or the probabilities, right? Which is just a number between 0 and 100. So you can think of what machine learning generates as a probability calculator, a model's a probability calculator, but it's got to have the right up to the moment inputs. So in addition to sort of this big archive of historical things from which to learn, we need that data pipeline that's serving up the current view for each and every piece of equipment that we're making predictions for. So, right, and that's from a predictive analytics or predictive AI standpoint. That's where Thing Zero comes in, right? And in this hypothetical example, we're talking about a company, that probably doesn't yet have a sort of consistent and coherent data lake that puts that all together. So, can you speak to that?
Yeah, thanks. And I think one of the things I want to talk about really before we talk about any solutions is this idea of walk, sort of crawl, walk, run, and how many. I was looking at a study that Microsoft put out. I think that was sponsored through the MIT Foundation, was around that less than 30%, which is validating your thing. Models end up going into production, but even further than that, it's that how do I take the data, democratize the data, and then be able to use it by the whole organization, not ending up with data islands, number one. Number two, connect securely and compliantly to my factories. Now, the stories that we've heard over the years of, you open a door into your factory network, you have machines sitting in there that are running, unsupported OSs, and because it's generally been a firewalled environment. So the point is, you want to take the opportunity to improve that, but not at the risk of, say, having your whole system ransomware. And so I think that's one of the issues, which is, hey, when we're connecting IT to OT, what is our infrastructure to meet the risk level that the companies are willing to tolerate? Number one, and then number two is, how do we make this as simple as possible. I think the history that we've seen here is that, and I certainly over my years in the last 20 years in consulting have been that you end up with 40 products or 20 products to do this, and that the company ends up being a system integrator to pull all these pieces together, and then you're managing all of that. So I think simplicity is got to be one of the important parts. Understanding what your total cost of ownership is. How are you going to run this? And that comes all the way down to your point of how do I make decisions, and are those decisions good ones, and what do they represent in terms of profitability? And then organizational change management. How do you roll this into an organization where people accept it, they understand it, they understand that their jobs aren't going away, they're just going to improve the bottom line of the company, and they will have better analytics to make decisions with, that their job is being augmented, that it's not being removed. I think one of our founders who was involved with us, he famously said, any operator who is an expert can manage a one or two lines perfectly, but trying to manage 5 lines with all of the instrumentation and changing that instrumentation to keep the quality within your upper and controller lower control limits is impossible. So this is where we're going to, is how do we start with, I have no connectivity, I want to know whether the machine's running and how much. Then I want to do that across all of my manufacturing estate. And then once I have that data, I can start thinking about where should I concentrate my effort to start building predictive models, and what are all the Pareto analysis, what does downtime or poor quality equal, and what's all the data inputs that I need to then build my model. So from there, I'm going to throw it kind of back to you and say, that's where we're taking the expertise of the two companies and your help at Think Zero to really say, we're going to invest, we're going to focus on kind of low hanging fruit, and we're going to start like creating a correlation to say, can in the data, can we see what's happening? And then can we then predict if we change this feed or speed that will continue to remain within our quality and have better utilization rate of equipment.
Right. I mean, and it sounds like you're starting to allude to a point that I think we wanted to hit today, which is that predictive maintenance, where you're just predicting yes, no, in a typical project, as far as is there going to be an outage or not in the next time increment, is just one of so many different possible use cases, both AI and otherwise. Once the data becomes cohesive and comprehensive, and accessible, so and in that sense, democratization as far as all the different kinds of organizational functions, both inside and outside the plant itself, having access to this data and being able to make use of it for all different kinds of business functions. Um, so what you just alluded to is also sort of more of an optimization. So there's one question is to sort of, how do you optimize when exactly to implement a maintenance procedure that decreases the chances of an unexpected outage. And that would typically be what's called binary. You're predicting yes, no, but there's also predicting how much, and you're trying to sort of more broadly optimize. This thing could be at some wide range of acceptable performance levels and output levels, but you want to try to keep it to the upper range. What are the main factors? So that's a pretty different kind of number crunching endeavor. What other kinds of business use cases do you see from what ends up being a more generally applicable data lake, even if it was originally conceived for predictive maintenance?
Yeah, no, I mean, I think this is the era we're moving into. I think eliminating the hype from the reality of it is that and I've heard from people that this is their field, these big data projects of trying to consolidate data in to be able to optimize my purchasing patterns or better forecast when I'm going to have deliveries. And so they end up with these big data models. And I think foundationally, if we look at what is the cash register of your business, and it's these operating technologies, which is I produce an output, and that output then I ship it, and that represents a good to society, right? And people go buy it, or however it's produced. But the point being is that as we move into manufacturing 4.0, these projects can be funded and managed through just the how do I optimize. Do I send a truck out for somebody to go climb up a tower to go fix something prior to the event happening? Like you said, this is sort of binary. And what's the economic cost of somebody getting in a truck and driving to somewhere? Or, your point, I'm going to take line number 2 down on shift 3, and we're going to retool it, and then we're going to have it back up on shift 1. And instead of running it through shift 3 and ending up on shift 1 with a bunch of bad product and the machine down. And so
Mhm.
you're preventing two things. One is you're continuing to keep your throughput for your financial economics of your company, but you're also making sure and reducing scrap rates and all that stuff that we want to do to improve, for environmental purposes, to meet our requirements, that we're not driving that truck off somewhere for something that wasn't needed to be done, right? So to your point, when we're the foundation of the project can be this, but now once you have the data, instead of it sitting there in a data island that's called IoT predictive maintenance, or OT predictive maintenance, or IIoT, whichever one of the acronyms we want to use, you've dropped it into a corporate data lake where somebody else can say, hey, I want to understand how often these 4 machines run, what's their throughput, because I want to buy another line, and which one's most cost effective. Or if we bumped our productivity up by 4% on this line, we could defer a capital purchase of a new line for another year, right? So now you're allowing the whole organization to make decisions based on how often this thing runs, which one has the best throughput, what has the best gross margins, and where should we focus our efforts.
Right. Yeah. So that fundamental visibility, the accessibility to data that represents uh, monitoring of the complete picture across all pieces of equipment, um, you very kind of quickly get to that. If predictive, in a sense, is the most advanced type of analytics, right? Because you're learning from data in a very particular way. It's sort of the rocket science part, so that you're doing as well as you can predicting the ultimate unknown, which is the future, putting odds on it, and acting on those odds, right? So in that way, we're not just we're improving responsiveness, right? So instead of just having a regularly scheduled maintenance or what have you, or any other kind of procedure, it's more dynamic. It's being responsive, and not just responsive to up to the minute, but responsive to the predicted future, to the odds on how things are going to go. So that's great. And that may, in a sense, be, in one sense, that's the lowest hanging fruit, because it speaks so directly to the pain point where, like, we have this huge manufacturing operation with 30% outage, depending on how you define outage, right? That's such a big pain point. And this is the ultimate way to address that. And yet it's not the lowest hanging fruit, in the sense that, the kinds of visibility questions that you were just asking, hey, I want to look at these types of equipment because I'm considering buying more. That's basically just database querying, right? There's no rocket science there, but you do need that fundamental data infrastructure. Which one of these two capabilities is going to have more ROI? Well, you could argue it. I mean, I'm in the machine learning field for a reason. I think that's got great returns, but it is certainly more complex. But it turns out that to do one, you're also creating the data lake that enables the other. So having that, whichever side you kind of start with, you're headed in the same direction, which is a universal data lake that serves all these different kinds of endeavors.
Yeah, no, 100%. And I think the point that you help us with, and that we focus on, is like the context, right? How do you keep context of your data, right? And so I just want to switch gears for a second, just kind of walking through, the thing zero value proposition, which is sort of at the edge. Am I, zero trust has now been around as a buzzword for many years. We understand exactly what it means in terms of it's not just one product, it's starting at one side. I'm opening a door at the factory to collect data. How do I make sure that bad people don't walk through that door? All the way up to I'm going to bring that up into a cloud. I'm going to start building my models, but first I have to do my data transformations. I have to make sure that my schema, I have to worry about privacy and security of that data. Then I need, the cleaning, aggregation, and combining, right? What other data do I want to combine with those data sets to give the whole picture? And then from there, it's like, what happened and why did it happen? So in that sense, when you're building your models, Eric, in the validating the model and that it represents the real world, what are the most, like, I don't, how do you get that part right? Why don't we say that?
As far as determining which predictive projects are going to generate the most returns.
No, more about, does my data represent
Mm.
the reality of, say, this manufacturing line and all of the things that affect it, right? And does it represent, does it, I can see what the failure modes are, and I can combine sort of like Pareto analysis to say, let's keep it simple. In an example, I'm machining a part and I start seeing that I'm starting to go out of tolerance, and I know that I need to replace the bit because that's what's causing the tolerance. So,
Mm.
so you're able to, whether it's you observe it or you're looking at the amount of power it's taking to cut the part, and so you make a correlation to say, well, power equals del bit. So how do you, when you're building these predictive machine learning models, what's the process? What's the gut check to say the model represents reality?
Yeah, that's a great question, and I'll first start with a general concept comment, which is addresses that, which is, you know, I, I think Thing Zero, it does something well that most companies are getting wrong, which is that as you have all the expertise for the data infrastructure, you know, data lake, whatever the form of that's going to be, um, you're not just focusing on that architecture and core technology in and of itself. You're focused on the value propositions, the use, including predictive use cases, right? What exactly needs to be in place for you to generate a viable, sound, and valuable predictive model, which is generally omitted, right? There's a tendency to just get into the tech of itself, the architecturing of these data infrastructures. Um, and then the predictive use cases kind of become an afterthought. So you're integrating and planning for it from the get-go in order to ensure the universal applicability of the data lake. But to answer your question, the data requirements for the predictive use cases, it's not rocket science. There is a rocket science involved, which is the machine learning method, the machine learning algorithm, the thing that does the number crunching, the thing that learns from data to predict, right? Uh, the the principles of that are not terribly hard to understand, but the devil can be in the detail. But the fact is, using it from a business standpoint um, can largely be seen as a black box. So long as there are data science experts on the project, because its inputs and outputs are not rocket science. As I mentioned, it needs to learn from a lot of examples of both the thing you're trying to predict and the opposite, the positive and negative cases of that outcome that you're trying to predict. And then the output in the end, as I've mentioned, is the odds, right? It's a probability. It's a number between 0 and 1 or 0 and 100, right? That's not a rocket science concept. People shy away from probability because it sounds intimidating or highly technical. But it's, and that's because there can be complex math to calculate it. But once it's been calculated, once you have this so-called probability calculator, is like the way I like to refer to a predictive model, then using it, it's like clockwork. probability is just a number between 0 and 100. We don't have a magic crystal ball. We have the next best thing, which is some sliding scale of how likely in this particular case for this particular piece of equipment that outcome is going to be positive or negative. The value of that is clear. And then the place where you got to get a little bit into the nitty gritty, but again, it's really just a semi-technical understanding. It's quite accessible. Is you have to be really, really clear of exactly what you're predicting. So you can't just say, "Hey, when's this machine going to have an outage?" You have to say, "Okay, we have these 5 measures of quality of the output of the machine. We're going to have some arithmetic that puts them together and decides whether the level of performance is, quote, acceptable or not, and draw a line. And in some way, we have to decide pragmatically, right, with experts on the factory floor, what counts as a positive and negative example, and define it clearly so that this probability calculator, well, what's it predicting, right? It's a probability of what? Well, that's the thing that everyone involved in the project from all sides and all disciplines need to get on the same page and agree on, needs to be defined. And by making that definition collaboratively, that's how you ensure that the right data is being collected and that the model is going to be viable for deployment.
Mm-hmm. Yeah, so that just brought two questions, but in your book, the AI playbook, you talk about where, like, okay, I want to offer somebody something to retain them as a customer, and so when do I invest, and how do I know whether that investment's going to pay off? And I think that's very much like the same idea of when do I do predictive maintenance and will that pay off, and the same sort of concepts, right? So it's getting the data right to be able to understand that if you do something, that the outcome has a certain probability of an outcome, in it. So completely understand what you're saying there, and how that applies. And I think, that foundationally we need to start the projects with stealing quotes, with the end in mind, and
Yeah.
understand what I need for scalability, what I need for security, what does democratization of my data need, what are my total costs of operating the system after, and then what, again, what will be my most likely outcome. So in this case, we're starting with 30% downtime. So we understand that every percentage of downtime probably drops through to the bottom line as a multiple of profitability, right? And so if you're starting with a big enough target, I think really the important part is that we build it with a POC with the end in mind. We go to the pilot to validate it so that we can start building our cost pieces, and then we have multiple waves that we're going to do, which is getting data visibility, bringing that to management, showing them, look, we can understand our uptime and our throughput. Now we're going to invest in understanding optimization through predictive maintenance, or through adjusting process controls as we're moving, and then ultimately being able to make financial decisions on, do we take the action or not. So in walking through that path, that's and I love what you wrote, and what the foundation of Goodter AI is really like. Think about the business model. Think about the outcomes of that. Think about that from the beginning. And like you said, don't get wrapped in the tech. But if we look at this with, so the question from the beginning, which was, why do 30% of most models don't, go? If we look at the studies that talk about that, is they didn't start with ROI. They didn't think about scalability. They didn't think about security. They didn't think about organizational change management. How are we going to get people to adopt this stuff? And all of that becomes the full package. And we get to this endpoint phase where we're making decisions based on data, based on probabilities, and those will affect, all the way through. Hey, we went from 30% down to 10%, and that 20% fell through to the bottom line in not having to buy capital equipment because I'm getting better throughput, having better quality, and I'm not having to do reworking my parts, or scrapping them. So all of those things end up there. And then, like you said, the cherry on all of this is really just like, okay, now I can collectively look in the organization and query that data and really start seeing patterns of things that I didn't see before. So,
Yeah.
yeah. Anything you want to add? Because I think we've done a great job of sort of talking through this. Let me
Yeah,
just
I think that everything you just said made sense, and there's challenges in infrastructure setups, and a lot of agreements need to be put in place to make change, to manage change, to motivate change. And the change is, look, instead of having for example, some kind of regimented, regularly scheduled maintenance um, process, it's going to be dynamic. It's going to be responsive to predictions. It's going to it might happen 3 times on Thursday, but 0 times on Friday. Right? It depends on what the model. We're going to do it by the numbers. Um, but that change ultimately is motivated by bottom line KPIs. And those types of monetary figures, savings, profit, however you want to measure it, that's on I mentioned data infrastructure usually sort of has a lack of visibility, a lack of planning around what the predictive use case is going to be. But then the predictive projects generally have a lack of visibility into the monetary value. So the idea of predicting and putting probabilities, you can measure how well it does that. You evaluate the predictive performance, typically in useful but arcane technical terms, rather than also including a monetary estimation. Hey, look, this is how well it predicts, and that translates into this dollars saved per week or what have you. So that's what we're doing at Goodter AI, and it's a critical part of the workflow as you start making initial pilot models, get a sense of not just how good the models are, but how valuable they are from a monetary standpoint.
fabulous. Couldn't agree more. 100%. I think the one that is like the most obvious one for me is you have a vehicle, you're supposed to take it in every 5,000 miles, right? And get the
Mm-hmm.
oil changed or
Mm-hmm.
whatever.
Yeah.
Less so in this electric era, but there's also this idea that your batteries, don't retain a charge for long. And when would I make a choice to change my batteries or whatever? So the if I'm driving back and forth to work on a road that is clean and it's not congested and stop and go traffic, or if I'm driving down a dusty road, if I look at the oil at 5,000 miles on those two, they're going to be significantly different, and they're going to have a significantly different impact on the life of my engine, right? So rather than just dumping out clean oil, if you can make the choice based on what is the optimized change to give the best life of my engine, now you're not spending cycles dropping your vehicle off at service, you're not dumping oil that doesn't need to be dumped. All of these things are the goodness that come out of it, and that's a very sort of simplistic
Yeah.
model, but
You're customizing it for your particular car, which is what the word we use is personalization when it's a customer facing, right? You don't say personalization for a car, but that's what you're doing. You're customizing for a car. And those are exactly the kinds of use cases. My first book, Predictive Analytics, has 183 mini case studies in the big color tables. So here's one brief list from that. Out of the 183, here's a bunch of examples for predictive maintenance. So making those predictions for individual satellites, nuclear reactors, manholes, train tracks, train wheels, office equipment, vehicles, um, buildings, etc. So yeah, I mean, and there's all of these things have been done.
that's fabulous. It's so great to be working together, both as you part of Thing Zero and also as a partner with Gooder AI. It's a fascinating journey we're going on. I think taking the hype out of this and focusing on the reality of results and building infrastructure that goes into production is our number one goal. It would
For sure.
not to be one of the 30%, only the 30% that go into production. So, and
Yeah, yeah.
it's really great to be working together on this project.
Yeah, likewise, Marvin.
Yeah. Thanks so much. Wishing you all the best. And hopefully we'll have the opportunity to get some feedback from people on this
Yeah.
as an output, and any questions that people want to field. We'll have contact information in here, and we'd love to hear what you think about it and your input and um, feedback about this session. Thanks so much.